Now if we go on increasing the pressure, now that means we are putting more and more weight over this piston, this will get compressed, and after some time, after some stage, increasing P, if we increase more pressure, x is the mass of adsorbate which is adsorbed on this surface, this x will not increase. That means the surface on which this adsorbate molecules were adsorbed, this will become saturated. That means no more adsorbate particles will be adsorbed now, and the pressure at which this phenomena happens is known as saturation pressure, because the surface is saturated now. Now if we draw a graph for this process, increasing pressure process, this x by m, this is mass of adsorbate over mass of adsorbent. Let's draw it against versus P. We have seen that first the graph will increase and then it will become flatten up, and the pressure where it has just flatten up, this pressure is known as saturation pressure. I hope I am clear. And this sketch which I have just drawn here, we have assumed at the starting that temperature is constant. See, I was discussing adsorption, isotherm. Adsorption, you know, adsorption is the process about which we are talking since last 2-3 videos. Now it is isotherm. Now what is the literal meaning of this iso? Iso means same and therm means temperature. That means the graph versus this x by m and P at a constant temperature is known as adsorption isotherm. I hope it's clear to all of you now. Now let's make it more clear. Now if we draw 2-3 graphs like this, one is like this, second one like this, and third one like this, this is x by m and this is pressure. Temperature is constant. We have seen the effect of temperature over adsorption. Adsorption decreases with increase in temperature. I hope you remember this. Now this is graph number 1, this is graph number 2, and this is graph number 3. These three processes represent, these three graphs represent the process. For example, let's take a system and its temperature is T1, and first its pressure was P1, then we increased, put some more weight P2, and plotted at this P1 how much mass X was adsorbed, and this P2, this P1 P2 will be pressure. Let's say this is P1 and P2, oh sorry, not here. Let's say this, at this P1 X amount of adsorbate what adsorbed, and at P2 X2 was adsorbed, and this graph represents that process, that how much variation is there X by m versus P. And similarly we have taken another system, this is kept at temperature T2, and similarly first P1 then P2, and we have drawn this graph. And similarly taken third system which is at temperature T3 and varied the pressure for this system, first P1 P2 P3 so on, and we have got a graph like this graph. Now pause the video and think over it. Will T1 be greater, T2 be greater, or T3 be greater? Obviously T1 will be greater than T2, and T2 will be greater than T3, because this x by m at this for this T1 is less than this. This is the x by m for T2, this is for T1, and this is for T3. T3 should be less than all of them, because at this temperature the mass of adsorbed on the surface, this is more than this, which is relatively more than this. I hope it's clear to all of you.